Welcome to class. Today, we're going to be learning about first-order linear equations and how to solve them. Quick refresher for you. If you recall, a first-order linear ODE has this form, where I've got some function of the independent variables only dy dx plus some function of independent variables only y equals some function of independent variables only. Now for this section, it's going to be helpful to actually adjust this notation a little bit. So what I'm going to do is I'm going to divide over by a1 of x. And what I'll get is that dy dx plus a0 over a1 times y equals g over a1. And do you notice this is still linear because all the coefficients still only depend on the independent variable. So if I just give this guy the label p now, and I just give this guy the label q, I'm going to write the linear equation in what we call standard form. Which is to say that dy dx plus some function of x, p times y, equals some function of q, some function q of x on the right-hand side. So standard form is just when we write our first order term with a coefficient of 1. Now let's look at a simple scenario. And hypothetically, let's suppose that q of x is 0 for now. When this is the case, do you notice that my equation actually becomes separable? I can move this term over. I can separate my variables and write dy over y equals negative p of x dx. I can integrate both sides now and write that natural log of absolute value of y equals the negative integral of p of x dx. I can exponentiate both sides, and I get that y is equal to e to the negative integral p of x dx. And I can drop those absolute values since that's always a positive quantity here. So what's really interesting is in the case that q of x is equal to 0, I actually know the solution already. There it is. But what happens when q of x is not equal to 0? You'll need to stay tuned to find out.